All right, so we're going to start our inference here by doing inference for a single proportion. You can look at the first video to see how I set things up, but we're going to do inference for a proportion. We're going to consider that same variable from, I think, last week, the self-employed or works for someone else. And we're going to consider the proportion of people who are self-employed. So we can compute it using a tally. We learned about that in lab 1, and I would encourage you to pause the video and see if you can figure out how to compute that sample proportion. And now I'm going to do it. So I'm going to tally, and I'm going to put a tilde because I just have one variable, and then it's self, emp, or works for somebody, comma, and then data equals GSS. If I control enter, I get it in terms of the absolute numbers, but I actually want proportion. So I'm going to say format equals proportion. And now it gives me the proportions. So about 10% of people are self-employed. And then we might need to compute our standard error. Now that we have our point estimate, we need our standard error. We can use our formula, and we could just use R as a calculator. Again, I'd encourage you to pause the video and see if you can compute the standard error yourself, and then see how you do it. So the way I'm going to do it is I'm just going to round to 0.1, and then I know that 1 minus 0.1 is 0.9. I'm going to put parentheses around those numbers, and then I'm going to divide by the n, which is the number of rows, 2348. 2348. And then I'm going to put a square root around the whole thing, SQRT, parenthesis, and then I'm going to get a little error here, unmatched opening bracket, because I need to close off that last parenthesis. Then I can control enter, and our standard error is 0.006. So when we do a confidence interval, we do our point estimate plus or minus a critical value times our standard error. We've got our point estimate, we've got our standard error, so then we need our critical value. And if we're doing inference about a proportion, we're using the normal distribution. It means we need a critical z-value. And you might have some critical z-values memorized. I do. I know it's 1.96 for a 95% confidence interval. But maybe you get asked to do a 90% interval or an 80% interval. You might need to compute it. So let's check and make sure that I'm right about this 1.96 thing. I'm going to use this function qnorm. And when I run that, it says 1.959964. It's that 1.96, so I was right. And the question is, why did I put 0.975 inside my parentheses? I was looking for a 95% confidence interval. Why didn't I put 0.95 there? And it has to do with the fact that R always computes the amount of the distribution that is to the left of the value. And so if we're looking to find a 95% confidence interval, if you think about the normal distribution, we've got 95% in the middle, and that means we have 2.5% in either tail. And so if we want the value for which 95% is in between, that's the 95% from the middle and a 2.5% from the tail, which is to the left of it. So because we need to add up everything to the left, which is 0.95 and 0.025, and the same thing would happen if you were doing any kind of other interval. You have to think about the middle plus one of the tails. But that confirmed my critical value. And so now we could use R like a calculator to compute our confidence interval. Our point estimate minus our critical value times our standard error, and our point estimate plus our critical value times our standard error. And so I could say I am 95% confident the true proportion of people who are self-employed is between, and I'll say 8.8% and 11%. So I'm just rounding. I'm not picky about rounding. We could also ask R to help us out. So we could use this prop.test function if we wanted to. And prop.test uses the same formula syntax. You do a tilde and then the variable, and then data is equal to, and then in this case, GSS. If I control enter, I'm going to get a bunch of stuff actually. So right now, what we want to focus on is this 95% confidence interval. And so this is the one that R computed. It's a little bit different. You know, I did some rounding up here, but it's essentially the same. So from 9% to 11.6%. So that would be our confidence interval. And the same thing is true for doing a hypothesis test. So that was for our confidence interval. If we wanted to do a hypothesis test, we wanted to know if the proportion of people who are self-employed is greater than 10%. We could write out our hypotheses. And again, I'm using LaTeX. P, I'm using /LEQ to mean less than or equal to. And then here I've got P greater than 0.1. So again, we can either use R as a calculator, or we could reuse that prop test function with a couple more arguments. I'm going to stick in a chunk, and I'm going to do that point estimate. So let's go find it. It was up here. And I'm going to use the full decimal so that I have something a little bit clearer. So I've got my point estimate minus my null value, and then I'm going to divide by my standard error. Let's find that. That was up here. And I'll just copy the whole thing. So our test statistic is negative 0.19. And then you could just think about whether you think that's going to be significant or not. You could pause the video and make a guess. And I know this is not significant because it is much less than 1.96. So if we think about the normal distribution, it needs to be out in the tails either less than negative 1.96 or greater than 1.96. And this is very close to the middle of the distribution, so it's not going to be significant. And I could figure out the p-value if I wanted to with this function pnorm, which is sort of like qnorm, but it works to find p-values. So I would give it this number, and then it would give me the p-value. And so our conclusion is to fail to reject because 0.42 is much greater than 0.05. So that's how we could use R as a calculator. We could also reuse this prop.test function. Again, we've got the tilde and then the variable that we want. We've got data equals GSS. We have to specify what success means, and in this case it's self-employed. So if I go look at the data, I have either someone else or self-employed. I have to tell R which category to count up. I have to tell it my alternative hypothesis, which is that it's greater than 0.1, and then I have to set my null value, p equal 0.1. So if I run this, again, I get kind of a lot of stuff. I get a p-value, which is pretty similar to the one that I found before. It's a little bit different. The prop test function is actually using the chi-squared distribution, not the normal distribution. And so you get a different test statistic and different kinds of things like that, but the same conclusion, that you would fail to reject the null hypothesis. So at the 5% level, we fail to reject. At the 1% level, we also fail to reject. And so this is because 0.35 is greater than 0.05, and again, because 0.35 is greater than 0.01. And I could put $ signs around it if I wanted it to be nice and mathy when I knitted the document.